afternoon, everybody. I'm studenti now at the University of Milan. Just slightly change the title, but not substantially. So, teachers grading on student social background, evidence from 26 million assessments. So it's rebranding. So, research aims. Just start with that. I start with a simple question. So how does a student's social background affect the way in which the students are graded by their teachers? And in particular, I'm interested in understanding heterogeneity and variation across subjects, so Italian and mathematics, school levels, and also student competencies level, on which there is not much evidence so far. Now, we know that in all the school systems in Italy, but of course also abroad, teachers are asked to regularly grade students. So teacher marks are an important pillar of every educational system functioning. Teacher marks matter for a lot of reasons. They matter for the signaling value that they have to students and their families. So it gives a powerful signal about the students' academic competencies. It might affect, let's say, later educational decisions and transitions. They might affect directly students' motivation and later effort. Of course, it also has some kind of effect on the possibility to, let's say, access colleges, universities, and also it might be taken into account by prospective employers in the labor market. And so if students maybe are exposed to what they might perceive to be unfair treatment, that could undermine their motivation and also trust in school institution. So it's pretty interesting and relevant issue in my opinion. If we talk about grading and socioeconomic origin, the relationship can go into different ways. In the first way, we might think that low SES children, so students coming from a lower socioeconomic background, could be over-assessed by their teachers compared to their demonstrated, let's say, ability. And in this case, teacher would tend to compensate for social inequalities in learning and achievement. Might be taken into consideration that the students come from a disadvantaged background and they want to, let's say, make a premium on their evaluation. On the other side, it could be the opposite. So high SES children could be over-assessed by their teachers, and in this case, teacher will give them, let's say, a higher level of grades compared to their demonstrated competencies, and this would, let's say, lead to a reproduction of social inequalities in education achievement. So the, let's say, theoretical estimate of this paper is what I call the SES-based grading mismatch, SGM, so far, which means the systematic average difference between the grades attributed to a specific category of students, in particular based on the socioeconomic background, and their demonstrated level of competence in that specific subject. So we will talk about over-assessment to indicate students who receive higher marks compared to their subject-specific competence. We will talk about under-assessment to speak about students who receive lower marks compared to their subject-specific competence. What is important to highlight is that this SES-based grading mismatch is not teacher bias or teacher discrimination per se. Okay, it's teacher bias and teacher discrimination can be one of the sources generating the SES-based grading mismatch. I will explain it in a few slides. Now, to better understand what is this, it's better to understand the genesis of the say grading in schools, and from the education and social science literature, we know that basically teacher grading standards and practices are the results of a complex assessment process, which reflect a lot of influences, students' characteristics, attitudes, behavior in classroom and at home, teacher characteristics and proclivities, student-teacher interaction, and characteristics of the classroom and the school environment. I will not enter into the details because I will not try to disentangle these channels, but it's important to keep it in mind. Now, I was mentioning before that the sources of the SES-based grading mismatch could be many I try to identify the most relevant ones stemming from the literature in economics of education, sociology of education, and educational science. I identify at least 5 groups of factors. The first one, coming from sociology, is cultural capital. So basically students' habitus, language proficiency, cultural resources could be better evaluated by teachers that can give a premium in terms of grades to students that demonstrates certain kinds of, let's say, social competence and cultural capital. Social and behavioral skills, they refer to more specific students' attitude and behavior, which are usually positively or negatively sanctioned by teachers. So teachers can decide to give a premium to students that well behave in the classroom, even if they have the same ability than others, because they make their life easier, they allow the class to proceed well, and so on. Another important source behind this could be parental involvement. So there could be parents that strive to, let's say, better grades for their children, and they are putting pressure on the teachers by trying to raising their evaluation. Others not. So that could also, and if this is stratified by social background, we know that high SES families tend to be more involved in the school career of their children. That could be part of this SGM. And then there are more, let's say, discrimination or biases explanation that might refer both to statistical discrimination, stereotypes, or, let's say, more taste discrimination, which I don't think it's a large part of the explanation. Now, research hypothesis. I have 3 main hypotheses. The first one is about the direction of the phenomenon that we are interested in. So if we follow many of the accounts that I rapidly outline, we should expect that higher SES students receive higher marks compared to low SES students, adjusting for, say, subject-specific competencies. What about subjects? Should we expect difference in SGM in mathematics or language? In theory, we should expect probably larger SGM in Italian reading than in mathematics. Why? Because, of course, in mathematics, usually you might be, teachers might use a more, let's say, standardized type of evaluation system, which should reduce this type of phenomenon. So this gap between the marks and the competencies. The last aspect is about whether actually the gap in grading is similar or varies along the student competencies distribution. So I try to outline 3 potential scenarios. The first one is a uniform advantage scenario, where basically says, okay, higher SES students are always over-assessed, even if they are low ability or they are high ability students. It doesn't matter. The second scenario, what I call the boosting advantage, actually means that actually the grading premium in favor of high SES students is particularly present for high achieving students. Okay? And the last one is a compensatory advantage, that is the reverse. It's basically actually the compensatory advantage says that basically we expect a stronger, let's say, gap among the low achieving students. In particular, high SES students, they say basically teachers might be more reticent to give a very bad mark to the sons and daughters of highly educated professionals than giving very high marks to the students from the working class. And I believe that the third should be probably the scenario in place, but we will see whether this is the case. Okay, in terms of analytical design, basically the identification of the SGM is based on the comparison between students' marks awarded by teachers and student competencies in standardized tests. There are, of course, some basic assumptions at the base of this design. First of all, teachers' grading reflect kind of direct knowledge of the students, and aspects other than the demonstrated competence are likely to enter teacher evaluations. The second is that standardized tests provide a kind of decontextualized or less subjective measure of student competencies, and that the third is important, is that there is no measurement error in the variable capturing student competencies. So test scores, we will discuss that. data, use the INVALSI data, so student population data with repeated cross-sections. For the moment, I focus on the years from 2011-12 to 2018-19, considering all the levels from 2nd, 5th, 6th, 8th, 10, and 13, and relying on list-wise case relation, we arrive at around 13 million students, and given that we have 2 evaluations per student, we are around 26 million evaluations. So the advantages of the INVALSI data are that we have comparable measure of marks and test scores. They are rather close in time, but not so much, but I think there are other advantages. I don't have time to enter into that. They have the same subjects, marks, and competencies, and they have similar content. So the INVALSI test, differently from the PISA, tries to measure curriculum-relevant knowledge and competencies. Teachers' marks come from school register, are not self-reported by students. We have large data, and we have the possibility of disaggregating, and we have the classroom identifier, so we can approximate a situation where we have a teacher, the same teacher evaluates students in the classroom, which is very good. So in the analysis, we use as outcome teacher marks in Italian and mathematics. Independent variable is the index of economic and sociocultural status developed by the INVALSI. I also tried with different indexes, and the results are the same. And the main control variable is the test scores in the INVALSI. Of course, for each mark in each subject, I control for the specific test. And just basic control variable, gender and migration. Now, the standard approach in doing this kind of analysis is called grade equation model. It basically is an OLS regression where you introduce first, you might introduce together social background or the category that you are interested in and controlling for test scores. This has some problems. First of all, it's not clear which is the theoretical estimate of interest. There is a risk of over-control since the test score is a mediator, is a, let's say, a variable that comes after a treatment variable, which is social background, and it usually doesn't explicitly control for the possible interaction between SES and test scores. So in this way, I propose another approach based on a causal mediation model rooted in a counterfactual framework, and I also include classroom fixed effects to approximate the situation of teachers assessing students in the same classroom. In this way, I remove, let's say, differential exposure to different kinds of teachers by SES. So this is a little bit technical. I will not enter into the details, but if you are interested, I can come back. So what we are interested in is the so-called direct effect of social background, which is in this framework called the natural direct effect. And when in the main analysis, in the heterogeneity analysis, I instead focus on the control direct effect and basically estimate the control direct effect for different percentile of the grade and court-specific distribution of test scores. So the 10, the 25th, 50, 75th, and 90 percentile. So let's go to the empirical results. So this is the social stratification of grades. So this is the total association between social background, so SE, SES, and teacher's marks by grade and year. So here we're not controlling for test scores. And what you see is that overall there is a positive association. So you see the zero, so all the estimates across the grades and across the years are both zero. It means that one standard deviation more on the ESES index is associated with higher marks, both in Italian and in mathematics. And the relationship is pretty stable over time. There's some variation, but not huge. Now, what happens to instead the natural direct effect, which is basically our estimate of interest? So, to what extent high SES students receive higher grades in reading and mathematics compared to the low SES that have the same subject-specific competence. Now, again, what we find, at least in the 2nd, 5th, and 8th grade, is that there is a positive direct effect of social background, which is pretty, it's not small. I can anticipate, not super big, but it's not small. And
we cannot hear you if you
cannot hear me. Okay. Now you can hear me? It's better? Thank you.
It's when you turn.
Yes. Yes. So what you see is basically that the time trends are almost stable in the second, in the 5th grade with an exception, and there is some evidence of a little bit declining SGM in the 8th grade. The situation is a little bit different in the 10th grade because you can see immediately, and you will see from the next slides, that actually this gap by SES is much smaller in upper secondary education. You can see it better here. It's the same data, same results, but with a different representation. Okay. Now you have by year, and you have how the SGM varies along the educational career. Okay. It's not in a panel way, so it's not longitudinal, but I did it also, and it's the same. And basically, what you see is that this SGM is positive. It's present in the 2nd, 5th until the 8th grade, and then it sharply declines at the 10th and the 13th grade. I will not show you here. Now, here you have the same thing, but in relative terms. Okay, so basically here I put at 100 the association between SES and marks, and then I want to understand what is more important in determining this association, the differential distribution of competencies or all the other factors. And basically the dark blue is, let's say, the direct effect of social origin. And what you see is basically actually the marks, teachers' marks, are only to a minor extent affected or depend on the demonstrated subject competencies as measured by the test scores. So here we see that the large part, more than 70% in some cases, so between 50 and 70% or 80, depends on the year and on the level. And this is in mathematics, okay? Not only reading, also in mathematics. So this means that basically there are many other characteristics that are taken into account by teachers beyond, let's say, subject-specific competence. Similar pattern found in reading. And then the last aspect was, again, we don't find huge differences across subjects. The last, maybe you cannot see very well, but the pattern is pretty straightforward. Remember, we were asking whether this SGM is larger or smaller along the ability or the competence distribution. The answer is there is evidence of a pattern of compensatory advantage, so smaller gaps for high achieving students, larger gaps for, let's say, lower achieving students in elementary school, especially 2nd and 5th grade, a little bit in the 6th grade, but not much afterwards. So afterwards, especially in 10th grade, you don't find much, and in the 8th grade, you find that the gap is almost constant. Very quickly, some further insights. So the effect size, as I anticipated, is substantial. It's larger than the gender effects, for instance, in the elementary school. In comparison with the models without the fixed effect, the estimate here is slightly reduced, so there is some evidence of teachers' allocation effects. If we compare these estimates with the standard models, we find that the standard model tend to underestimate the gaps. And if you decompose the different components of social background, what is more important is mother's education. And partly also father education, and if the father is unemployed is particularly important. So in conclusions, 5 bullet points. First of all, we found a large association between social background and teachers' marks, both in mathematics and in reading. We found that the direct effect of social origin is larger than the indirect effect for student competencies. Third aspect is the SES-based grade mismatch is larger in primary and lower secondary education. It declines to be quite small in upper secondary education. It's pretty stable over time with only minor fluctuations. And we found evidence of a compensatory advantage model, so smaller gaps for high achieving students, especially in elementary school. The next steps are basically to add the post-COVID cohorts to see whether the patterns changed, putting together the results also into a meta-analytical framework, and also taking measurement error in test scores. I did some preliminary check. It doesn't matter so much. The results are pretty there. And again, doing more comparison with gender and also migration background gaps. Thank you very much.